title of the next blank page is on the board. We are going to be using some graph paper.
I'm just going to
We are going to be working with graph paper today. We're going to be both in our notebook and on graph paper. All right, so we're going to be working both on our graph paper and in our notebooks. We wanted to have both available. Our question today is, what are all the possible dimensions for a rectangle with an area of 12 square units? Before we do that, let's just think about what does this back half of our question mean? What does it mean to have a rectangle with an area of 12 square units? What does that even mean? I should see lots and lots of hands because we've definitely talked about this. Lincoln, what does that mean?
It has to be 12 square units long.
Not 12 square units long. It could be, but think about we're talking about area.
The dimension always has to be considered 12?
Nope, not quite. But thank you for paying attention, raising your hand, giving a thought. Shelby? The inside of our shape, which is a rectangle, has to have 12 square units. Use your graph paper. See if you can come up with a rectangle that has 12 units. Notice I said rectangle, not a crazy shape. 12 squares on the inside. If you can come up with one and you draw it on your notebook, give me a secret thumb. If you've got a rectangle with 12 units on the inside, 12 squares on the inside, give me a secret thumb. Draw. What did we draw? What were the dimensions of the shape that you drew? Will, what did you draw?
I drew a 4x3.
A 4x3. What is Will talking about? Will said, I drew a 4x3. Jackson, put your book away, please. What is Will talking about? Gwen, what is he talking about?
When Will says he drew a 4x3, he means like there was 4 on the top and 3 on the sides.
Yeah, he's talking about our dimensions. He's talking about length and width. When I'm counting dimensions, look up here. I count the side of my square, so that's 1, 2, 3, 4. There's my 4. 4x3 means that I now need to move to my other dimension. 1, 2, 3. Will, you just drew an L?
No.
No. He made the whole rectangle. We're only talking about 2 dimensions because we know that if one side is 4, the other side has to be 4. And same with our 3. Give me 2 signal if you also drew a 4x3. If you did not draw a 4x3, draw it on your paper. If you did not draw a 4x3, draw it on your paper. I didn't ask for that. Michael, did you draw a different shape?
No, but why don't you, instead of calling it a 3x4, why don't you take the 4 and the 4 and add it, and then the 3 and the 3 and add it, and then make it whatever 8 plus 6 is, and then add that up and whatever it is.
So we're trying to measure 2 different things. When I say area, my area, I'm talking about the inside space. When you were talking about adding my dimensions on the outside, 4 plus 4 plus 3 plus 3, is that measuring my inside space? So what you're talking about measuring is called perimeter, the outside. And that will work if I want to know the perimeter. But if I want to know the area, do I need to add up how much it takes me to go around it? No, I need to figure out how many squares are going to be on that inside. Sean, I saw that you had a different shape. Well, same shape, but different dimensions. What did you have?
I did 2 by 6.
A 2 by 6. What does that mean? Sean drew a 2 by 6. What does that mean? What does that mean? Sit up, please. What does that mean, a 2 by 6?
2 down,
Okay, so maybe 2 rows
and then across goes 6.
and then 6 columns. 1, 2, 3, 4, 5, 6.
And then
I'm looking at Sean's, and I know that he didn't draw it sideways like that. Is that okay?
it doesn't really matter because it's still the same.
Yeah, my
Still the same
value
amount.
is still going to be the same, even though this one is turned sideways.
I can find it turning upside
We've
down.
got a 2 by 6. If you don't have a 2 by 6, draw it on your paper.
I drew 2 by 6.
So we've got a 2 by 6. We've got a 3 by 4. Did anyone come out with another one? There's at least one more. Sit up, please. Brandon?
A 1 by 12.
A 1 by 12. If you don't have that, draw it on your paper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
It goes like all the way down.
Mm-hmm. That's 1 by 12. I noticed Logan drew his sideways. Is that okay?
Yeah.
Yeah.
Because it goes the same.
1 by 12, whether it goes vertical or sideways, is not going to change my area.
You say that.
It's not going to go diagonal because then I won't have straight lines. Because then I'll be cutting across my squares and we're not doing all that.
You always say
On
that.
like a regular.
Alright, in your notebook, let's list the squares, or sorry, the rectangles that we drew. So we drew a 3 by 4. We're writing in our notebook. We also drew a 2 by 6.
Maybe a 4 by 3 too.
And we also drew a 1 by 12. What are we noticing about those 3 dimensions? What are you noticing? Michael?
About the rectangles.
No, about the 3 dimensions we just wrote in our notebook. 3 by 4, 2 by 6, and 1 by 12.
I have 2 things.
Okay.
They all the area is all of them.
Yep.
And it counts like I think in a pattern kind of.
Okay. Okay. What else are we noticing? What else are we noticing? Devin, what are you noticing?
Noticing that every time when we make different numbers for it, it still equals the same thing.
Yeah. Do we see that each multiplication equation we just wrote equals 12? These are just rows and columns. 3 rows by 4 rows is equal to 12. 2 rows by 6 rows is equal to 12. And 1 row of 12 is equal to 12. Sean? Boom.
It has like 1, 2, and 3 that goes up, and then in the
the other part of it is
Mhm.
4, 6, 12.
Mhm.
It's kind of like counting by twos, but kind of like, and then it skips count to like counting by like eights.
We are doubling one factor and then having another one. Doubling and then having. Yep. Bladen?
Is there any more equations that could do it besides or backwards?
There are no other rectangle equations. So Bladen said except for the ones that are backwards, so he's talking about 4 groups of 3 would obviously work, 6 groups of 2, 12 groups of 1. Any other factors? Nope, that's it. Just those 3
For multiplication?
for a area of 12.
Then area
Okay,
13.
well, quickly. All right, what I would like you to do is cut out the rectangles you just did. Try not to cut your paper all up because we need that graph paper. Cut them out and glue them next to where we wrote the dimensions in your notebook. I'm going to go ahead and read our next problem. If you're still gluing, undertaking please quickly. We're going to go ahead and start thinking about this next problem. Jessica is building a sandbox with her dad. She wants it to have an area of 24 feet, but isn't sure what is the best size rectangle to use to build the sandbox. Find at least 2 options for Jessica that has an area of 24 feet. What am I going to be counting? Am I counting around the shape or am I counting the inside of a shape? What is it that I'm going to be counting, Devin? I'm counting the inside. I am trying to find an area of 24 feet. How many squares am I going to need inside that shape? How many squares am I going to need inside that shape? Braden? 24. 24. When you're ready, use those graph paper scraps and see if you can figure out a way, that's okay, see if you can figure out a way to make a rectangle that has 24 squares on the inside, an area of 24. Alright, what are some shapes, some dimensions that you figured out? Can I tell you a trick? So I was thinking on our last one, we did a 1 by 12, and that equaled 12. If I wanted to use that to help me, what do you think I could do to get to an area of 24?
2 by 12.
Layden, what are you thinking?
A 2 by 12.
A 2 by 12. 2 groups of 12 is going to be how much, Layden? 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I've got 2 groups of 12, which has an area of 24. If you did not draw a 2 by 12, draw one somewhere on your graph paper. Are there other options? Yes, there are. Yes, there are. Lincoln, what's another option I have to get to an area of 24?
A 6 by 4?
A 6 by 4. 6 groups of 4. 1, 2, 3, 4, 5, 6. 6 groups of 4 gets me to 24. So I've got a 2 by 12. I've got a 6 by 4.
I don't have a number.
Any other options? Logan?
3 by 8.
A 3 by 8.
They'll have roll here. Can't even put one. No, we don't have room for just one of the shapes. So I have room for two.
All right, so we've got quite a few options.
Cut it in half.
I want you, Michael, do you have another option?
Yeah.
What is it?
1 by 4.
Oh, 1 by 24. Do you have 24 squares?
No.
So a 1 by 24 mathematically will work. We don't have enough squares to make that work on our graph paper.
Up and down.
Mike, let me ask you this question. Do you think that's going to be the best rectangle for a sandbox? A 1 by 24?
No.
Probably not.
Neither is the 2.
I want you to pick out 2 options that we made that you believe would be the best options for an area of 24 sandbox and glue them in your notebook.
Just
Yep. We're only cutting out 2. So in our notebook, we've got area of 24 sandbox. 1, 2, 3. Eyes on me.
1, 2, eyes on you.
Some of you chose to talk to your neighbor during that time, so we'll say this again in your notebook. In your notebook, you're going to write area of 24 sandbox. You're going to cut out 2 of the options, the 2 options that you think are the best options for the sandbox, and then glue them in your notebook. So what I noticed in our sandbox, we had a couple of options. We figured out that a 1 by 24 would work. It's not the best option, but it would work. We figured out, Will, that a 2 by 12 would work. We figured out that a 3 by 8 would work. And we figured out that a 4 by 6 would work.
I be right here.
You're already there.
Well, since right there, so I could be on the track.
You're already there.
What?
You're already there.
What do you mean? Why is it here?
What I have noticed is that all of these multiply to give me what product? Well, 24. When I am thinking what are my options of a sandbox with 24? I could be thinking, what factors are going to multiply? Because I know area and arrays go together. What factors are going to multiply to give me 24? All right, we're going to do one more. So turn to the next blank page in your notebook, because I'm sure you're going to need it. Here's our last one. It says, Miss Ritchie is making a bulletin board to display the math project her class created. She wants to have an area, and switch these options, of 32 square feet. Find at least 2 options of rectangles with an area of 32 feet squared, square feet for Miss Ritchie. Before I give you new graph paper, because some of you are going to need new graph paper, how could we start thinking about this problem before we even draw it? Think about what we just noticed in our last one. How can I start thinking about what my dimensions are going to be? Shelby? Well, it's not going to go by 12. That's not what we just talked about. What did we just talk about? If your eyes are looking somewhere else, that might be why we don't know what we just talked about.
Yes, ma'am.
Sean?
What was the question again? I was like,
How can we start thinking about what's going to be our dimensions of 32 square feet?
just started thinking about as I mentioned, just by knowing what's half of 32 feet. So you do like something times 2 or like something like that.
I want you to write blank times blank equals 32 square feet.
Where?
We're writing this on the next blank page in your notebook. So I just said that there title. Yeah, we're just writing blank times blank equals 32 square feet. We know that 32 square feet is our area.
No.
Hang on.
I'm
Now that's
asking
our
about that.
area.
I'm asking something about that.
We know that we are going to multiply because we need an array. An array means that we're counting area. Why do we need to multiply? It's not a trick question, I just told you. Brayden, why do we need to multiply?
Because we need to multiply this number and that number to get to 32 square feet.
No, that's not what I said. Why do we need to multiply? Will? No. We need to multiply to make an array. Why do we need to multiply?
To make an array.
We need to make an array with our squares because that's how we find the area. We're multiplying to make an array. And then we count our array, and that's our area. These other boxes, here and here, those are our dimensions. So, Will, when you're talking about length times width, this is where they are. Our dimensions, if we want to go back to the land of arrays, these are our rows and columns. When we hear dimensions, when we hear length and width, I want you to think rows and columns. Emily, what should you be thinking about when you hear length and width? Rows and columns. Blaine, what should you be thinking about when you hear dimensions? Rows and columns. Think way back when we first learned multiplication, way back in September, October, we were making arrays. We're doing the same thing. The same thing. We're just calling it a different name. Shelby? Yes, which is why it's a little frustrating when some of you are not paying attention and doing other things with your body. Michael?
So like really like all the math subjects that we do like simple school addition, subtracting and adding and all that, dividing, they're all basically like they all kind of connect. But then like in division you can also use multiplication, but then some people like overthink it when it's really just multiplication.
Yeah, they do all connect. That's why I like area. It's a good reminder of stuff we've already done. Alright, if you need new graph paper, I'm going to come around and give you some graph paper. If you think you have room on what you have left, you can go ahead and start trying to figure out, what's going to give us an area of 32? I want to challenge you. I did not say get up. That was not any part of my direction. I want to challenge you to start thinking, I know that I need dimensions. I know I need rows and columns. What do I know that will multiply, make an array of 32? Who rose to the challenge? Who figured it out? School of you figured it out? Love it.
Totally.
When? What were your dimensions?
4 by 8.
A 4 by 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I know that 4 groups of 8 is equal to 32. 4 by 8 will work. If you didn't have a 4 by 8, draw it. I love that I'm seeing some of you still working on some other options. Logan, what'd you come up with?
2 by 14.
So close. So close.
No.
A 2 by...
I'm trying to do that.
It's not 14. You are
Sure.
super, super close though.
It's really,
2 by 16. 2 by 72. No, it's 2 by 16. No, it's 16.
16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Because I know that 2 groups of 16 will equal 32. Lincoln, you got one?
1 times 32.
1 group of 32. I know we don't have 32 squares on this paper. Jacob, have a seat, please. But that will definitely work. That'll get us an area. I'm glad to see some of you are using your multiplication knowledge. And I know 1 times 32 is 32. All right. We're going to cut out both of these and glue them underneath where we have just written that our area is equal to our array. So go ahead and cut those out, please.